Hello everyone, welcome to my channel. In this video I have this integral to look at. It's the integral of 2 to the power x all over 1 plus 4 to the power x dx. Now the approach, as you would guess, is that we have to write 4 to the power x in base 2 and then carry on from there as follows. So we have the integral of 2 to the power x all over 1 plus 4 to the power x dx. Now, like I was saying, this is the same as the integral of 2 to the power x all over 1 plus, remember, 4 is 2 to the power 2, but we have a power of x over here, and then we have to say dx. Now remove the brackets. What we have now is the integral of 2 to the power x all over 1 plus 2 to the power 2x dx. I'm going to introduce brackets again because I want to write 2 to the power x and then raise the whole thing to the power 2 as follows. So this is going to be, watch how I'm going to transform this integral now. It's the integral of 1 all over 1 plus 2 to the power x, the whole expression, power 2, and then I'm going to say multiply this by 2 to the power x dx. You'll understand shortly why I'm doing that. At this point, I'm going to let u be equal to 2 to the power x, as you would imagine, taking us to the next page, page 2. So what we have now is, let me bring this page down so that you can see where I'm going and where I'm coming from. Right, so okay, now what I'm saying is I'm now going to let u be equal to 2 to the power x, and because I have an exponential function on the right hand side, I'm going to take the natural log on both sides. So this implies the natural log of u is equal to the natural log of 2 power x. Applying laws of logs, if I may remind you, one specific law of logs I'm going to use here is the following. I'm going to use this law of logs. The natural log of t power alpha is equal to alpha times the natural log of t. The power multiplies. So basically, if you look at this form here, is that form there, taking t to be equal to 2 and alpha to be equal to x. And then I need this form to get to the answer. So basically, I'm saying to you that this is implies that the natural log of u is equal to x times the natural log of 2. Fantastic. At this stage, I'm going to differentiate with respect to x on both sides. So now I'm saying that implies the derivative with respect to x of the natural log of u must be the same as the derivative with respect to x of x times the natural log of 2. Now on the left hand side, we're going to use chain rule, remember, and how we differentiate logs. Reciprocate the expression in front of log. So we have 1 over u times du dx. That's how you work on this one. On the right hand side, remember, natural log of 2 is a constant, take it out. Natural log of 2 and then times derivative with respect to x of x. Remember, here we use power rule. And how does it work? If you allow me to use this page, x, remember, is the same as x to the power 1. And when you differentiate this derivative with respect to x of x power 1, you're going to take the power, multiply, and then reduce the power by 1. And what is this? 1 times x power 0. This is 1 times 1, assuming x is not equal to 0. And what is our final answer? 1. So therefore, what we have on the right hand side now is going to be as follows. On the left, obviously, nothing changes. 1 over u times du dx. On the left, on the right is natural log of 2 times 1, because that's 1 I just showed you. And therefore now I have to multiply by dx both sides. So what I have now is 1 over u du on the left. On the right, I have natural log of 2 dx. Now I have to get rid of u, multiply it both sides, and then I have du equals something. Taking us to the next page, page 3, and I'm moving this down. Right, you can see there. Yes, correct. So now what I'm saying is, what we have now is du on the left. On the right, we have u, natural log of 2 dx. But what is u? We need to go back to page 2. If you go back to page 2, which is just this page here, u is 2 to the power x. I'm bringing that expression there in that place. So what I have now is the following. Now I have this implies du is equal to 2 to the power x times natural log of 2 dx. Now if we move back to page 1, I think page 1, if you remember page 1 down here, I said we need this form. Now if you look at this part here is exactly that 2x times dx. So it means I must get rid of the natural log on the right hand side. So I divide as follows. So let me just put this one here. We're coming back to that. So basically I'm saying that what we have is du over the natural log of 2 is equal to 2 power x times dx. Fantastic. Now look at this one here and this one here. Exactly the same. So now where there is 2 power x dx, I have to replace it, substitute that expression there. So now we're saying this integral therefore changes. Therefore, the integral 1 over 1 plus 2 power x all squared times 2 power x dx changes to the integral of 1 all over 1 plus, remember there's a square here, we're squaring the whole expression. What is 2 to the power x? Coming back to this page here, 2 to the power x is u. So this is u squared times, what is 2 power x dx? The answer is 2 to the power x dx. I just showed you on this page here, I just showed you, let me just check where we are at. Just on this page. So here it is. 2 to the power x dx is just du over natural log of 2. So I'm bringing du here over natural log of 2 there. And then I take natural log of 2 to the left, out of the integral. Remember it's dividing. So this is the same as 1 over natural log of 2 times the integral of 1 all over 1 plus u squared du. Now, those that have been practicing integration will agree with me that this is actually the arctan. If you evaluate that integral, it's the arctan of u, this one here. But I want to show you how that one is done. So I'm going to take step by step. At this point, I'm going to use time substitution, taking us to page 4, and hopefully to just complete this. So time substitution on that one goes as follows. In case someone may have forgotten, we just need to remind you. Tan substitution works as follows. So we're now going to let tan theta be equal to u. Two equations obtained from this. The first one is theta will be arctan or tan inverse of u. The second one is to differentiate both sides with respect to u. So derivative with respect to u of tan theta must be equal to derivative with respect to u of u. If you remember, this is similar to derivative with respect to x of x. It must give you 1. And so using this understanding, this should also give you 1 on the right hand side. So on the right hand side we have 1. On the left hand side, remember we're going to have to use chain rule now. Differentiate tangent and then theta. So derivative of tangent is sec squared. And then we have to say d theta du equals that. Multiply both sides by du. It simplifies to sec squared of theta d theta is equal to du. Now where I see du, I must put this expression in that integral there, as you can see, in that integral. So therefore we are going to say that integral, allow me to just put an arrow here, and so that integral is the same as 1 over natural log of 2 times the integral of 1 all over 1 plus, remember where there's u, I must put tan, and we have u squared there. So this has to be tan squared of theta, and instead of du, I'm going to have sec squared theta d theta. Sec squared theta d theta, like that. Now again, using a trig identity, a special trig identity is this one here. sine squared of theta plus cos squared of theta equals 1. Divide both sides or throughout by cos squared of theta, assuming cos squared of theta is not equal to 0. We have sine squared of theta over cos squared of theta plus cos squared of theta over cos squared of theta equals 1 over cos squared of theta. You'll agree with me, this is just tan squared of theta plus 1 obviously equals, that's your sec squared of theta. So where I say this, I must put sec squared of theta. So we have sec squared of theta in the denominator, and therefore our integral simplifies as follows. This is going to be 1 over natural log of 2 times the integral of 1 over sec squared of theta times sec squared of theta d theta. As you can agree with me, this cancels that. And so what do we have now? Page 5, to just finish this off, what we have now is the following. We have 1 over natural log of 2 times the integral of 1 d theta, and that, you'll agree with me, is just 1 over natural log of 2 times theta, and we have to say plus c as our constant of integration. And obviously you must remember that c is actually a natural number, a real number. C is a real number, so not necessary to say that, but you may have seen it in some cases where they write plus c and then they say c is an element of real numbers, like so. But we're not gonna do that here, it's not necessary. All right, so now moving forward, we must move back. What is theta? So this is 1 over natural log of 2. Reverting to our original variable, we move to u first. Theta is tan inverse of u, so this is tan inverse of u plus c. We move back again. What is u with respect to x? Because remember our very original variable is x, and here we go. U is equal to 2 to the power x. So where there is u, I must put 2 to the power x as follows, just to complete this. So this is equal to a tan inverse of 2 to the power x all over natural log of 2 and then plus c as our final solution to which integral I'll show you just now, as our final solution to our integral in this video, this one here. The final solution boils down to that. All right, I hope you found this useful. Tell me what you think. If you're new to the channel, like I always say, support us by subscribing, sharing these videos with your friends. It will help us grow the channel and give us the ability to generate many more videos and support as many students as we possibly can. If you're watching this from TikTok, you can actually check the link in my bio to my YouTube channel, and then you'll see many more videos there on integration, statistics and physics and chemistry as well. All right, I'll see you in the next one.